Here in this video, we are going to see a problem on isometric projections in which we are going to convert the given 2D view into a 3D diagram, that is the isometric view. For that, here is a question. Figure shows two views of an object. Draw its isometric view. Now, here are the two views which are given to us. As we can see here, this view onto the left hand side is the front view, and here whichever is there onto the right hand side, that is the side view. And we have to draw the isometric view. It means when we complete the drawing and then we are looking from front, the object should look something like this, and when we are looking it from the side, it should look in this way. So before we start the isometric projections, we should know how much is the total length, height and width of the object. So in case of front view, we are going to see the length and height, and as I can see here, the length is 60 mm and the height is 20 plus 32 plus 20, that is 72 mm. So I'll mention it here. Length is 60 mm, height 72 mm, and width, we can see it in the side view, it is 50 mm. Now, after getting the total length, height and width of the object, now I have to complete this drawing. So it would be started in a proper sequence and I'll explain it step by step. That is what we have to do in this problem. Drawing a light horizontal line. Next, marking a point over it. So this will be the reference point, and from here I'll measure an angle 30° on both the sides, because in case of isometric drawing, the surface is inclined at 30° and measuring 90° as well. So drawing a light vertical line. Now, after drawing these lines, that is here the two lines are inclined at 30° and a vertical line. Next, in the problem, they have given the origin in the front view, as I can see here, and even in the side view. Origin is that point which is close to the observer, or we can say the reference point. So in this diagram, here will be the origin. This is the origin for us. And now when the object is kept on the origin, like if I lift it from the front view, and when I'm keeping the front view on this side, then origin is here and length should be along this line. So the length of the object will be marked here, height on this side and width over here. So marking the total length, which is 60 mm, total height is 72 mm, and the total width is 50 mm. I can take this point. So drawing a light vertical line through the length, which is 60 mm, then through the width, which is 50 mm, then the total height is 72 mm, which I have marked here. So parallel to it, I'm drawing a line along the width. So here I'll be drawing parallel lines. So this is the block inside which I would be drawing the complete figure. Here we have the length, height and width. Now in case of isometric projections or isometric views, we have to go step by step. That is, instead of drawing it completely, we are going to draw it in steps. Like for example, here if I can see, if I can simplify this diagram, then in this diagram there are two plates or two blocks. One is the vertical block, other is the horizontal block, and both are intersecting. So the first thing would be, for me it would be simpler to draw the block which is behind first. And why I'm using this procedure, we can get that into the problem when we move further. So first I would be drawing this block. Its width is 20 mm and its height is 52 mm and length is throughout. So I'm going to plot that block. For that, here I'm measuring the width as 20 mm and then drawing a light line parallel to the length. Next, I will be projecting these points with the help of vertical lines. Light vertical lines. Then measuring a height of 52 mm. After that, here is the vertical surface, and then there is this horizontal surface which I am drawing here, the horizontal block. Now, as it is clear here, I have drawn two blocks. One is the vertical one, other is the horizontal block, inside which I have to draw the complete drawing. Now, I'll be drawing the vertical surface first. And if we look from front, this surface, when I am taking 20 mm height from the above, it is having inclination of 60 degree on both the sides. So this surface I have to draw it here in the front. But in order to draw that surface, I won't be measuring this 60 degree angle directly onto this diagram, because here the surfaces are already inclined to 30 degree. So if I am measuring 60 degree over these same lines, that will add 30 and give me the answer as 90 degree. So it is better in case of isometric projections that whichever angles are given, like for example 60 degree here, it is better to draw the surface somewhere else and then copy this surface onto this inclined, we can say, surface, which is the vertical surface here. So I'll explain the method how to do that. First I'm drawing this surface as it is along this side. Let us get started. Drawing a light vertical line. Next, a light horizontal line. Then this surface is having a height of 60 and its length, that is from this point to this point, the length is 60 mm. So I'm drawing a rectangle of length 60, that is measuring 30 mm on both the sides. So measuring 60 mm length. Next, drawing vertical lines through them. Then measuring 20 mm. And now here I am measuring the angle 60 degree from both these points as it is given. So measuring 60 degree from both the corners, drawing light lines through them. And now this is the surface, which is the surface which we are seeing from front, which I am going to copy and plot it here. So I'll make it dark. Now after drawing this surface, first I'll plot the center here, like I've drawn the center line here. Same will be on this surface, taking half of 60, that is 30 mm, drawing a light vertical center line. Now in the compass, I'm going to measure the distance from the center up to one end. Same will be the distance on the other side. So I'm taking this reference point and marking the points over here. So this is the method we should use in case of isometric projections. Whenever we have some angle in between the drawing, we have to take that angle somewhere different from the drawing, and then we have to copy it back, because in case of isometric projections, the lines are already inclined at 30 degree. So if we measure any angle over these lines, we are going to get the value more than 30, because 30 will already be added. So it is better to draw any given surface which is at a particular angle. In this case, the surfaces are inclined at 60 degree. So it would be better to draw them differently and then copy it onto the diagram itself. Now next I can say that as this surface is having a height of 20 mm, the same 20 mm which I am getting here, I am just going to mark it over that. So I am measuring this distance of 20 mm, plotting it over these vertical lines, then drawing light lines. Next, here I am getting this surface, and in case of isometric projections, the surfaces are 3D, that is three dimensional. So once I've got the surface as a 2D figure, it is having a width of 20 mm. So that width I'm going to project it back, projecting it back with the help of light lines. And now these are complete surfaces. So parallel to this surface, I am drawing a line joining these 2 points. So here is that vertical surface. Now something interesting, inside this vertical surface there is a circular hole of 20 mm diameter. As I can see in the front view, it is a circle, and in the side view that circle is dotted. It means it is a square hole. It is a circular hole and not a circular block. So I am next going to draw this circular hole having diameter 20 mm. So I'll explain the procedure how it should be drawn, because circles in case of isometric projections, they won't be looking at as circles on the plane. That is, we cannot directly measure the radius and draw the circle onto these surfaces, because these surfaces are not normal surfaces. These are inclined surfaces, already inclined at 30 degree. So in order to draw the circle over such surfaces, that circle would be changed. It would look like an ellipse. And now I'm going to draw that ellipse over this surface having diameter 20 mm. So here, for that circle having diameter 20 mm, its center is located at 20 mm from top. So measuring 20 mm distance, and then drawing a parallel line through it. Now here I am getting that center. Since the diameter is 20 mm, I'll measure 10 mm on one side, 10 mm on the other side. So 20 mm. Similarly, onto the vertical line, measuring 20 mm, that is taking 10 on both the sides. Then through these 4 points, I'm going to draw parallel lines. Like for example, from the point which is there at the top, I'll measure a line parallel to the length. Like parallel line. Through these points, I am drawing the vertical lines. Now, I have to draw that circle inside this parallelogram because that is the method we follow in case of isometric projections. So in order to draw the parallelogram, the first step is, in this parallelogram, I have to draw the longer diagonal. So if we can see here, the longer diagonal is on this side. I am drawing it light so that we can see the longer diagonal. Here is this longer diagonal. Next, connect the upper midpoint to its opposite corner in such a way that it should cut the longer diagonal. Like for example, here there is the upper midpoint. I am going to connect it to this opposite corner, and in that way it is going to cut this longer diagonal. Similarly, onto the other side, like here I have taken the upper corner or an upper midpoint. Now I am taking the bottom midpoint. It would be joined to its opposite corner such that it is cutting this longer diagonal. And now, when the longer diagonal is being cut with the help of these two lines, now I am going to mark the centers. So where they are cutting the longer diagonal, I am getting one center point, and this is the other center point. So next, I am going to draw the circular part, which is when looking from the front, or in case of isometric projections, this is the way in which a circle should be drawn. So I'll explain that method. Like, take this center point and adjust this radius with the help of a light arc. Join these 2 points. Next, in a similar manner, take the other center as a reference. Take this distance as the radius. And join these 2 points. Light. Next, I have to draw arcs here. So connecting them, take this center, adjust the distance, taking this as the radius. Drawing a light arc. Next, from the opposite corner to this center, take this center and this much radius, that is up to these points. Draw a light arc. Now once I have drawn this circle, in case of isometric view, light, now I can make it dark. In this way, the circle will look like in case of isometric projections, and this circle is deep as I can see here into the side view. This circle is 20 mm deep. So if we take the center 20 mm behind, like for example, I'll show it here. If I take any of the center, like for example, this center 20 mm behind, in that case, that center is crossing the diagram. So whenever I would be drawing these arcs, they are going to cross the diagram. And suppose instead of that, if I take the top center ahead and try to draw it, I'll explain it how it should be done, because we have to check the depth whether the circle would be seen along the depth or not. For that, instead of taking the bottom center as I've explained, it is crossing the diagram, and here I'm taking this top center with the help of light line behind, measuring 20 mm over it. And now I can just check whether it is intersecting the diagram, because if it would be intersecting the diagram, in that case we don't have to draw that circle. Like measuring the same radius, I'll just show an example. So now, as I was explaining, shifting the center 20 mm behind, and then taking the same radius which I had taken previously, same radius. Now, as we can see, this arc is crossing the diagram, and when it crosses the diagram, we don't have to draw it because there are no intersections inside this isometric drawing. If this arc, suppose take an example, if this arc would have been coming inside, then I would have drawn it directly. But here, since it is crossing the diagram, I won't be drawing it. So it means we have to leave this circular hole as it is, and it will be understood that this hole is throughout. Next, after completing up till here, I can see that inside this bottom plate there is a semicircular hole or groove which is cut, as it can be seen from the side view. That semicircular hole is up to a width of 15 mm. So the next step would be to draw this semicircle, and again, as I've explained for the circle, even in case of the semicircle, when you are drawing it in case of isometric projections, you won't be drawing it directly. That is, directly I cannot take the radius 10 and just draw the semicircle in case of isometric projections. Here, I'll have to use the same procedure as I have used for the circle, and the centers are matching. So the vertical center line which I have projected, that same will be transferred onto this horizontal surface parallel to the width. It has been transferred. Now I have to draw this semicircle, taking this center point as the reference. Radius is 10 mm, so the diameter is 20 mm. So from both the sides, I'll measure 10 mm on one side, 10 mm on other side. That gives me the value as 20 mm. Next, drawing vertical lines through them. Then from these 2 points, I'm measuring 10 mm on one side, 10 mm on the other side. Drawing parallel lines. So this is the parallelogram inside which I'm going to draw the semicircle. And again, the procedure is same as it was for the circle. That is, first drawing the longer diagonal. So here I'll join these 2 points and get the longer diagonal. Next, here I have the midpoint of these two sides, and from the top also, from the top side, I'm going to take its midpoint, and from the bottom as well. Next, in a similar manner, here also, as I have connected for the circle the top midpoint to the bottom opposite corner, similarly this top midpoint will be connected to the bottom opposite corner, and the bottom midpoint to the top opposite corner. And now, where these two lines are cutting the longer diagonal, I am getting the two centers here, and I have to draw the semicircular portion. So for that, I'll take the distance from this center and taking this much radius, drawing a light arc. Then, since it is a semicircle, I want that semicircle only up to this particular point. So for that, I have to take the radius from this side. That is, this will be my center point, and here I have to measure this radius because I cannot take this point as the center point, because here the semicircle would be completing, that is, it would be going into the diagram and we are getting the circle. So no need of this center point, but this center point is required, which will give us the bottom arc. Drawing it with the help of a light arc. Next, as I have drawn this arc, the next step would be, since the semicircle is 15 mm behind, so I have to take its points 15 mm behind. For that, from here, I am taking this point behind. So these are the limits inside which the semicircle will be drawn. Taking 15 mm behind, measuring the 15 mm distance. Now, here I would be drawing the semicircular part 15 mm behind, and for that, I'll have to take the centers 15 mm behind. Like for example, first I had taken this center, so taking it behind by 15 mm, drawing a light horizontal line. Over that, I am marking 15 mm. And then at the same time, I am taking this center also 15 mm behind, which is there at the top. Taking the same radius which I had taken for this longer arc, and taking the new center which is 15 mm, I'm going to draw that arc up to its distance. As I was explaining, this is the radius and the center is shifted. Drawing a light arc. And now for the next arc, this distance is very small, so we cannot draw the arc further. I will stop it up till here, and then I'll make them dark. Now, once I have completed this, the remaining part is very simple. That is just I have to make these surfaces dark, and for that, starting with the semicircular part, I am connecting both the semicircles so that it looks like a complete surface. So this is the semicircular groove which we are going to see from the front. Next, if we see this diagram here also, as the surfaces are inclined and in the side view there is a dark line between these two surfaces that indicates change of plane. So when I look into the front, I can say that the surface which is at the top, that is inclined, and the bottom surface is straight, which is vertical. So I'm making it dark. So these are the surfaces which I'm drawing. Now both the vertical and horizontal blocks are connected, so I'm connecting them. So these lines are connected as I am showing here. This is a continuous line, and these are continuous surfaces, 3D surfaces, because we are drawing isometric projections or isometric views. Now, once I have completed this drawing, here if we see from the front view, I'll say that this is the direction because I have projected the length along this inclined line. So this is the direction X along which we are going to see the front view. So we can just check after completing that whatever we have drawn, is it correct or not. So in that case, if I'm looking from front, the object is looking like this. That is, the vertical plate is seen along with the circular hole and inclined lines. Horizontal plate is seen, which is having semicircular hole in that. So here there is a semicircular hole or groove up to 15 mm depth. Next, between the vertical and horizontal blocks, there will be a dark line like in this orthographic drawing that indicates change of plane. So that change of plane I have shown here with the help of this vertical and horizontal surfaces on different planes. Then when we are looking from side, in that case, between these two planes, as they are not onto the same plane, one is inclined, other is perpendicular, so there is dark line in between them. Next, there is a circular hole. From the side view it is not seen, so it will be hidden. It is hidden here. And then there is a semicircular groove inside this bottom plate, and semicircular groove is shown with the help of dotted line. And here we complete the drawing. And remember, whenever we are drawing isometric projections or isometric views, we don't need to give the dimensions here. That is, we have to just complete this 3D drawing and no need of giving the dimensions. So in short, isometric drawings are those drawings in which we are converting any given 2D figure into a 3D figure, and then we can check it either the solution which we have drawn it is perfect or not with the help of the given question. So with this we complete the problem.